welcome back to the unit testing for our developers. I'm Jonathan City, and with me is Daniel Sabanas-Bove. We're going to be discussing more of the ideas and philosophies behind unit testing in this episode. So we are going to be talking about, as we said, the philosophy, and that there's not really a need to be scared of unit testing. And we're going to show how you can gain more confidence in your testing framework by examining coverage and planning your tests for success. So what is the structure of unit tests? So first you set up the inputs for the unit tests. Then you compute the result which will be tested. You set expectations for the results of the test. And you compare the actual outputs with the expected results. This should allow for the code to have specific or functionality of the package itself. So you want to test for functionality and not general ideas in the package. Because if your action does too many things at once, you're going to be searching longer for the bugs, and we'll go into that idea in more detail. So there's all kinds of people that are looking at your tests, and you can think of this diagram as who are the stakeholders for it. So in the center is you today that is writing tests for yourself. The next layer is actually future you, because Daniel, as we know, in 3 months, nobody remembers what they actually wanted to do when they were developing. Is that right?
Yeah, that's right. I like that. Today versus future you. Yeah. Definitely applies to me. That I'm very grateful for the tests I wrote in the past.
Yeah. And then if you're collaborating beyond you and future you with other people, then the tests are a way for everyone to communicate what's the constraints of the package, what are the assumptions underneath the hood, what are the expectations for functionality. So all of that is encompassed in the unit tests that are running against the code that the team is working on. Next layer would be if your team is, let's say, posting a package on GitHub, other developers are going to be looking at the package, hopefully, and trying to understand, is your package having enough unit tests to have confidence that it does what you say it does. And if they want to create a pull request or add to your package or improve it in any way, then unit tests are a way for both you and them to have confidence that what they're adding doesn't break anything. And they can learn from what is already in the unit test of what you've checked. So that's the second to last. And the last one is CRAN, which all of us hopefully submit to improve the community. And CRAN actually runs all your tests for you on a continuous loop across many different platforms. So they check it against Windows and Mac OS and Linux and all the different flavors of Linux. So your tests need to be able to run against all those different platforms in order to be accepted in CRAN. So Daniel, there's the ability to run it in our hub. Can you explain a bit what our hub is?
Yeah, so do we have a slide on that? No, but our hub is basically another platform where you can basically submit your package to run the tests on the different platforms and also on the platforms that CRAN hosts. So RHub is basically a way to kind of check your package before you submit it to cron, in order basically not to have too many cron iterations back and forth, but just having those iterations with RHub is much easier. RHub also has a nice kind of package interface that actually allows to submit your package directly from your R session. I learned recently about that. That's also very useful. And maybe just a comment on this. I think it's also the potentially other users on other in other companies or other organizations that would be very grateful for this test, because that's really a way for them to check if on their platform, whatever platform they have, and maybe what other dependencies, versions of the other dependency versions they have installed, to make sure for them that the package actually runs as you intended it to run, right? Yeah, and for example, I have one very eye-opening how to say example recently when we worked on the MMM package. We were developing it mostly on Linux systems. Also, the continuous integration on GitHub was on Linux. And then just shortly before submitting to cron, I thought, okay, I give it a try now on a Mac system, on a Mac OS system, and on a Windows system. And it actually turned out that like hundreds of tests failed miserably, and while they were actually running fine on Linux. So that was kind of eye-opening, and then fortunately I could quickly fix it. But it is, especially if you have compiled code in your package, you might have like huge platform differences, and really the tests are the only way to know that this happens before you actually get like angry users filing bug reports to you.
I can definitely know about the angry users from other development. We'll touch into a bit later about reverse dependencies that CRAN does check, but those are actually something that is very useful for people maintaining packages on CRAN, and we'll touch upon that a bit later. So there are different flavors of unit tests that we can write. One of them is what we call developer tests. Those tests help the software developer speed up and iterate over different versions. And then there are the quality assurance tests. So that's proving that the package isn't broken or that functions are returning expected answers. So they're different. They have different purposes, these two different flavors, but both are very important to have inside your suite of unit tests. So I'll start with the QA test. The list is a bit shorter there. So in QA tests, some examples are to encode the object requirements. So the class of an object, or if you know the dimensions of an object that you're expecting. If there's a tolerance that you're expecting for, let's say, a simulation or some kind of fit that you're running in your package, then you can measure how much you're within a certain allowable range from the unit test, from the expectation to the actual output. So there's all of those very important tests to have, but they're different than the developer tests. The developer tests are meant to speed up iterations of development. So the first group, we can say they remove the fear of change. So they assist with the package design and the guide for refactoring. So a lot of the tests people can use in order to allow for being able to change small pieces of your actual package functions. And let's say you have a first draft of a rough function that you want to write. You put in the tests up front in order to see that it works, but then any refactoring that you do is going to check against those basic tests that you wrote. So the function will be doing the same thing, how it achieves that is going to change. So as you change your structure of the functions or a group of functions, you still have an anchor of the tests that you can check against. I know MMRM has gone through many iterations of refactoring, and the unit tests help keep a certain baseline of functionality that we want to expect. Right, Daniel?
Yeah, exactly. And that also goes a little bit into the test-driven development paradigm, right?
Yeah.
That basically before you actually write your actual package function, maybe based on your prototype code, you write first a test with some basic results comparisons, and then you write your actual package function. And then you basically, instead of just testing in the terminal interactively whether the stuff actually works, it's then much easier because you can just always run the tests.
Yep. And the second group of the developer tests we call reduced development time. So what this means is that we want tests that are small, quick, and flexible. So what that means is that if a test gives you an error, you want to have it on a specific functionality or characteristic of what you're trying to achieve. If it's too broad, the test will point you in the general direction, but you're going to be expending a lot of energy in order to actually figure out what went wrong. So we want to be able to construct tests that pinpoint errors. And also, the tests themselves for other developers can explain the code and what it's supposed to be doing, at least, to other developers. So you can think of it as comments, same idea as comments in the code. So the unit tests are your very actionable comments. Instead of putting it in the function itself, you can actually just code it and have an expectations for the functionality. So as you develop, you are reducing your development time because the tests are very specific to a functionality, and you don't have to go through any debug in your code to put in the debug call in your code or manual testing through examples. You can just run your tests and you will be able to diagnose the error right away and pivot and refactor and go forward.
Yeah, that's really important.
So planning tests for success. So we write tests to evaluate the exported behavior that the package user would invoke. This means that we set up the ability to refactor the code, and the test will not have to be rewritten as the package iterates and improves. So that goes to what Daniel was saying before, that if you have a baseline idea of what the package and the functions are supposed to do, you write the tests up front, and then you can improve the package as you go along, but you'll always have that the spine of the package be the unit tests, where that's the guiding light for all the different pieces of functions that you want to develop over time. Or if you're adding a new feature, that feature needs to be able to have unit tests for expectations of what the feature is supposed to do, and then you can quickly move on that.
Maybe just a comment here that it's also still very important to still also maybe have at least some basic tests for internal functions. So even behavior that's not exported, you want to make sure that it still kind of works correctly, because otherwise you might be in a situation that you have maybe a thin exported let's say interface on top, and maybe something fails, but then you would still need to kind of debug inside in the large internal thing underneath where actually internally it fails. So it's still also important to have some basic stuff for internal functions, and you might, and you also still need to expect that as you then refactor your package internals, you will then also need to adapt your internal tests, of course. Sometimes that will mean maybe you get rid of an internal function, you replace it by another, So the tests also need to be replaced. So there is some work with that, but I think it's still, yeah, it's almost still indispensable to also have tests for that.
So writing tests that you will not need to update or maintain because of a dependency. So you can't control how other maintainers are developing their packages and managing their life cycle. So it's important to, as you write your tests, to be able to make them as generalizable and low level as possible. That way, if something does break due to a different package, you'll be able to isolate it. Because you obviously you can't, if you're importing and depending on 10, 15 other packages, you'll end up chasing your own tail if you're depending on too much of the functionality of the other packages and not testing for that. You have to have unit tests that allow dependency changes to be detected early enough. So this is where CRAN is running a reverse dependency checks for accepting new package versions. So Daniel, do you want to explain what that is?
Yeah, so basically that's one nice bonus you get from CRAN by having your package on CRAN, because if you depend, for example, let's say on ggplot2, and ggplot2 is about to be updated, so RStudio is preparing a new version, and this would actually break your package, and this will be detected by a test in your package, then actually the RStudio team will be notified by CRAN that they would break your package, and then maybe they will start communicating with you about this, and you will be able to fix your package on CRAN using maybe that new development version, or maybe make it more general, like Joni said. But it basically allows you to detect this stuff very early before users would detect it, right? The worst thing would be to wait without a test until a user would install the new ggplot2 version and your package, and it would just be a bug. It would just fail for the user, right? That's kind of the thing you want to avoid, and that's really what you get kind of for free by tests and having your package on CRAN. You get this reverse dependency checks bonus, basically.
There's also a package that you can, I think, it used to be in DevTools. I think it's a different package now. You can invoke the reverse dependency checks from locally, so you don't have to wait for CRAN to run it for you. You can do that before submission to CRAN. And then as if, let's say, you are pushing a new version of a package, you can check the reverse dependencies before you move it to CRAN. So that's also something that you can be proactive in doing that.
That's nice if you really have then such a package that others depend on. Yes, that's cool.
Yeah. So we've been talking about what's called surface areas a bit. In the previous slides, we alluded to it. Now we're going to actually formalize it a bit. So what are surface areas of tests? So when writing unit tests for functions, it's important to take into account the surface area of a test. So here we have an example of a function, the mean function in the stats package. So the diagram here was created by a package called Flow, and you can find it on GitHub or on CRAN. And what it does, it takes all of the code in a function and creates a flow chart of the decision points in the function itself. You can also then break down your function into different pieces and see what does each unit test actually encompass when you write it. So let's say test C, if I was to create a test for that whole bottom branch, if something breaks, there's a lot of moving pieces in that unit tests that I have to go and search and look what actually broke of all those decision points. Test B is a bit smaller, but still I have to figure out what piece actually broke. But test A is testing a single thing. And if it breaks, I know exactly what broke. So there's a kind of a give and take on, do you want to have a lot of tests that check every little thing in the package? Or do you want to have less tests that have a bit larger surface area, but then may slow down your iteration of development if something breaks? So Daniel, I know that we all have that decision when we write unit tests. There are some packages that have thousands of tests that are hard to manage as a developer to write that many tests, but I think it helps in the long run if you can diagnose exactly what goes wrong in the package.
Yeah, I agree. And I think we will later see the different tests, how they complement each other, and we have those different trade-offs between number and surface area. Yeah.
So adding new features with a safety net. So when you are developing new features in a package, make sure to prepare the area with unit tests for the expected behavior of the feature. This will serve two main options: to communicate the goals of the feature to others and to yourself. So usually when a new feature is added, a lot of times it happens out of necessity, and you kind of ad hoc it and start to write the feature, and then later you add the unit tests in order to figure out what it does. And it helps you kind of hone your idea. But as if you are adding a new feature, it could react with other pieces of the package that you never intended for it to interact with. So it could just break the whole package and you wouldn't know. So having the guardrails put in place to have unit tests before adding the feature to the package really helps bring down the time if something goes wrong. And we all make mistakes and we all add stuff that breaks stuff all the time. But if you're keeping some guardrails on, you could really help yourself a month later when you're looking of why the package isn't working exactly right. And then you figure out it's this small thing in a feature that you added that you never intended for it to break.
Yeah. And this is again going to test-driven development, like similar like what we mentioned before. Yeah.
So some strategies for learning how to work with tests, so or how to write unit tests in an efficient way. So the best way is to pair up with an experienced developer or a group of developers, a pod, and read the as you are working together with them, you'll learn their best practices and have conversations about the code and learn much quicker than with yourself. Second one is help out with refactoring or features on GitHub repositories. So developers usually list what they are working on, and that we're really happy to get an extra pair of hands to tackle issues that we have. So being able to create a pull request and get feedback from the developer of the package of things that you may have not known about the package or unit tests in general, you'll get that direct feedback from them, and you'll be able to learn also pretty quickly. The third way is to clone repositories of packages you're familiar with and run the test you find there. So there's tons of packages, a lot of unit tests just in the wild. and also the ones that you're familiar with on CRAN, they're developed usually on GitHub. So you can just clone the package repository and step through the tests themselves and get I remember when I started to understand unit testing, I would clone packages that Jim Hester wrote. He was a long time in our studio and developed, was one of the main developers of tidyverse, basically. So just going through his code and asking questions about it, and developers are usually pretty nice people in R. So sending opening an issue or sending a message to the developers, they're usually happy to answer and teach other people how to do that.
Yeah, this is really helpful, and especially maybe if you want to write tests that do something similar to the package you're familiar with, that can be super helpful.
Yeah. Learn about base R itself from the unit tests of other developers. So usually tests are written most of the time in base functions. As we said, you don't want to depend on other packages in your unit tests themselves. So more experienced developers have a much larger wealth of knowledge about how to use the base package in order to achieve all kinds of results. So just seeing their code is a way to learn R.
Yeah, that's a good point.
What can and should be unit tested? So script can be unit tested. So single files with functions can have unit tests to them. Packages, obviously, which is a standard object to write for tests. Shiny apps can be tested, so you can write tests for the UI, and also the reactivity can be tested. So any part of the Shiny app can be unit tested. Data derivation is also something that can be tested and set expectations. So if you're creating a large data set that has a lot of derived variables in it, you can pre-write all the expectations and then pass the object to the unit tests, and then you can get a report of if it passed all the basic requirements that make that data set. So if you're working in collaboration with other people, let's say on university or in say pharma, which both of us work in, a lot of structured data sets are passed back and forth and updated. So if you're getting different cuts of the data, and you can run tests against a new cut to see is it has the same expectations as the previous one. So if, let's say, you were running a model and the model didn't work all of a sudden, then you have to first ask, is the data the same structurally wise, or is there something that the derived variable wasn't exactly calculated correctly and it's throwing your model off? That can be a week's worth of work to figure that out, and then you're frustrated and go back and ask why is the data not structured the same. So if you have a test, you can keep that time wise very short and be able to actually focus on the modeling and not the data.
Yeah, that's a good point. I mean, and I had examples also from scripts and so on, and especially also if you go into more complicated things like Stan code, for example, even that stuff can be unit tested in some way, and that it just gives you like the kind of reviewer perspective on your own code, your current you and your kind of reviewer you or something, developer you and review you, and that can also help to make more quickly progress.
So overview of unit testing frameworks. So for scripts and packages, there's TestStat, Tiny Test, Box, RUnit. Those are 4 that you can use. For Shiny apps, there's Shiny Test 2, Reactor, and what's called Cry, which was developed by Colin Fay. Data, there's Point Blank, Asserdar, Validate, Data Reporter. And for plots, there's VDiffR, so that's regression testing for plots. Testing plot functions. So the VDiffR package allows to save vector graphic files, so SVGs, of the expected plot outcome. This gives you more of an object to work against, so that you can evaluate the binary contents of the SVG file to see that you're getting the same vector graphic information. This works both for base plots and for ggplot. One thing to be aware of is false positive tests. The operating system can lead to slightly different plot outcomes, so the binary data won't be exactly the same, which requires manual visual checks. So that's the downside of this regression testing, is that it could be that even if it wasn't a false positive and something did break, you still have to, it goes to the coverage idea. You have very wide coverage of that test. So you don't know exactly what went wrong, but you know something did go wrong. And now you have to expend a lot of energy and resources to figure out, did it go wrong? And so it could be in the end that you do figure out it's a false positive, but you have to expend a lot of energy for that kind of regression testing, which is not great for when you want to move fast and develop on a tight timeline. So one alternative for ggplot is to use the layer data function to extract the layer information, and then use that as an expectation object to compare. That will tell, you can then break down that layer data into specific things within that object, and write more fine-grained tests to see if a specific aesthetic or something about the layer changed from what you're expecting. So that will be much more productive than going against a vector graphic. How do we communicate tests, the coverage of the test? So basically the benchmark for all the packages is a package called cover. So it's an R package that evaluates the percent of the lines of code that are tested. So it calculates the percent, but also it will, every time your unit test hits a function line, so you can have like 3 unit tests that all of them hit a specific line. So that line will be hit 3 times. So you're not counting 3 hits, you're counting that that line was hit at least once. So that's the what cover does. The function package coverage will analyze the current package coverage, and then one of the limitations of cover was that is that it's mainly in the language of developers, the outputs that it gives, and it's not human readable for regular R users. There's a package called cover page, which basically takes all the statistics that cover gives back and creates a simple README that you can place in the tests subdirectory, and it will give information regarding the overall coverage, break it down by the functions of the package, and then further break it down for the unit testing what each unit test evaluated, where it evaluated it, and if it passed, skipped, or failed. So it's a very concise report that gives you all the information you need extracted from cover and test that. So we're going to define here a map that will help us create a consistent language going forward about where on this this map are unit tests that are being constructed. So the basic outline of it is, so the y-axis is the coverage of the tests. So you want to go up to the top, and more coverage is better. And then the x-axis is the surface area. So the less surface area, the better. So if we take, let's say you have no tests. So no tests will give you no coverage. So that's why it's at the bottom. Snapshots, which are similar to VDIFR outputs for SVGs. So those are tests, they're regression tests. They give you a certain amount of information, but their surface area is very low, and they don't necessarily give coverage for the package itself. Examples like the ones that we have using our Oxygen 2, those are, in a way, those are tests. They get run for RCMD check. So they do have a certain amount of quality as tests, but they usually have very low coverage, and they don't have high percent coverage of the package usually. Bad tests are the worst out of all of these. Those are tests that are very broad, and they don't actually cover much of the package itself. So it could be that you have like 1 or 2 tests that maintain the whole package, and that is not helpful really for development. It doesn't give a lot of information to other users when they look at it. And also, if something breaks, you don't have a good roadmap of what broke. So you want to get as far to the top right as you can.
Yeah, and then within the top right, then we have again these different flavors: developer tests versus QA tests, and they kind of complement each other.
So in summary, we've talked about the philosophy of testing. So aggregate all the tests should cover the whole functionality of the package. Each test on its own should be specific and only have a small surface. There are 2 flavors of test: developer versus quality assurance tests. We can also test not just packages, we can test scripts, apps, and data. We discussed how to communicate test coverage. First, you would use cover to calculate the coverage, and then you can use cover page in order to communicate that coverage in a summary report within the package itself.
Awesome. Thanks a lot, Yoni. This was great. And cover page, I think, is really cool to have this nice report. So yeah, so how can we further automate this?
So going forward, we'll show how do you create what's called continuous integration and continuous development platforms, how to utilize those platforms in order to run your tests automatically for you. So you can run them locally through unit test, through test that when you're developing your package on your machine. But as we said, there's when you're working together with other people, or you want to test against other platforms, you have to utilize more resources. So we'll explain how to set up an action, what's called a GitHub action, in order to run your tests automatically for you.
Great. Thanks a lot, Yoni.
Sure.
Yeah, and check out the Software Engineering Working Group website if you haven't done so yet. And yeah, looking forward to the next session soon. Thanks, Yoni.
Thank you. Bye-bye.
Bye-bye.